Okay, guys. I'm now recording. um, so if so, what we're talking about here, we're saying that anytime we have two masses and we want to know the gravitational force between those two masses, that's where we're going to use our equation for universal gravitation. Okay. So what is the equation for universal gravitation? So the equation for universal gravitation is just this: is the force of gravity between any two objects is equal to uh, the gravitational constant big G times the mass of the first object, which is in kilograms, times the mass of the second object in kilograms. All of that divided by the distance between the object centers squared. So this is the equation we're going to be using today, guys. That is the equation for the force of gravity between any two objects. So let me write down, even though I said it, I want to write down what each of these terms mean. So okay, so guys, this big G right here, this letter big G, that stands for the universal gravitational constant. And it's just that, it's what it sounds like. It's a constant. And the constant has been measured to be 6.67 times 10 to the negative 11. And that number is always there in your equation. It's 6.67 times 10 to the negative 11. So that's what big G is. Okay. M1 obviously stands for the mass of the first object. M1, mass of the first object. M2 stands for the mass of the second object. And lastly, guys, whenever you see R in this equation, R just stands for distance. Specifically, it's the distance between the centers of the two objects. So R stands for the distance between again, I just want everybody to be clear what either of those terms mean in that equation. So R stands for the difference between the object's centers. So everybody got that? So if I
Yeah.
were you, if I were you guys, I would write this equation down. I mean, you don't have to, but it's just good to. So G is the mass of the first objects. I'm sorry, G is the universal gravitational constant, which is always 6.67 times 10 to the negative 11. So that number stays constant in every problem that you work on. Times M1, which is mass of the first object, times M2, which is mass of the second object, divide that by R squared, where it's understood that R is the distance between the object's centers. Okay. Okay. So hopefully everybody got that. I want to be sure I go over what each of these variables mean before we start working out problems. Now, um, one more thing. One more thing that I want to say. before we start working out some problems. I want to be very clear that everybody understand what R means because a lot of students always get this confused. I want to be sure everybody understands what R means. Christine, you told me you were going to get here on time next time. What happened?
I'm at work.
You're at work?
Yeah.
How you at work and at school too?
Cause I'm on break, so they let me use my phone.
What? How you on break and you supposed to be in school?
Because I need the money. Can you not mark me absent? Please. Thank you.
Christine, I think you are trying to give me a headache on purpose. I think you're doing it deliberately. You're trying to give Mr. Taylor
No,
a
I'm
headache on
not.
purpose. Yes, you are.
I'm not.
Yes, Eric, it is algebra based. And Stephanie, no, I'm not. Okay. Anyway, I just want to be clear that everybody understands what R means. Guys, suppose I have two objects that are sitting directly next to each other. This is mass 1, and then this is mass 2. And suppose I wanted to know what the gravitational force of attraction between these two objects are. Okay. Now, guys, in order to calculate the gravitational force of attraction, I first need to understand what R is, because I need to plug in R in this equation, assuming I know these masses. Now, guys, let me ask you a question. If the radius of one of these spheres, so let's say the radius of one of these spheres is equal to 6 meters. Okay. Can someone tell me if the radius of one of these spheres is equal to 6 meters, what am I going to put in this equation for R? Can someone tell me in the chat box? Assuming the radius of one of those spheres is 6 meters, what goes into the equation for R? I want to be sure everybody understands this.
You have to put the number 6 somewhere.
Remember what I said what R means. R specifically means the distance between the centers of the two objects. So it's the total distance between the centers of the two objects. So guys, what in this case, in this particular example right here, what is R? Can anyone tell me? It's not 6.
You mean R is in radius?
No. In this particular equation right here, what R means the distance between the object centers. It does not mean radius. I'm saying if you have two spheres that are directly next to each other and they're touching, what exactly is R?
That means it's 0.
No, the distance is not 1. Anyone else? It's not 0. It's not 1. Come on, guys. It is 12. Exactly, Angelina. It is 12. Because think about it. This is the center of this sphere here. This is the center of this sphere here. R always represents the total distance between those two centers. So in other words, guys, if you want to know what is the distance between this point and this point, it's just 12. Does that make sense? Now, everybody got that? Guys, that's important.
Yeah.
So y'all see this on the test, y'all understand it. So, okay. Yeah. That's what R means. In this equation, R always means the distance between the object centers. So if this distance is 6 meters and this distance is 6 meters, that means the total distance from here to here is 12. Okay. So please keep it in mind. R always means the distance between the object centers. In this specific equation, R does not mean radius. It means the distance between the object centers. I don't know why they use an R in that case, but just know that's what R means. R stands for the distance between the object centers. Okay, now, with that said, let us do our first example. Let's see, which one of these two ones do I want to do? I want to work out a mathematical problem first. Let me see. Okay, guys, let us do this one right here. Okay. Guys, if you have this assignment opened up, go ahead, turn to this, or go ahead and scroll to this problem right here. Okay, so this problem right here says object 1 has a mass of 5.7 times 10 to the 6 kilograms. Object 2 has a mass of 4.3 times 10 to the 9 kilograms. The centers of both objects are 1,000 meters apart. What is the gravitational force between the two objects? Okay, so I want to show you guys how to set up this problem and put it in your calculator correctly to get the right answer. So we're going to use this equation right here to work out this problem because we're solving for the gravitational force between the two objects. Okay, so I'm gonna open up a new page and I'm gonna walk y'all through how to set this up. So the equation for the force of gravity, okay, notice what I said the equation for the force of gravity is equal to big G. Guys, big G is going to always go in your equation. What is big G? Is 6.67 times 10 to the negative 11. So this number is going to go in every single problem. 6.67 times 10 to the negative 11. So the force of gravity is equal to big G. All of that multiplied by the mass of the first object. What is the mass of the first object, guys? Look at your units. Mass is always in kilograms. So 5.67 times 10 to the 6 kilograms. So let's write that. Times 5.7 times 10 to the 6 kilograms. Okay. So big G times mass of the first object times mass of the second object. What is the mass of the second object here? It says object 2 has a mass of 4.3 times 10 to the 9 kilograms. So all of that multiplied by 4.3 times 10 to the 9 kilograms. And then all of that gets divided by R squared. Remember, what is R? R is the distance between the two centers. It says the centers of both objects are 1,000 meters apart. So meters. So we know our units are correct because we're dealing with distance. So I'm going to put 1,000 and then squared. Okay. So guys, in your equation, remember R always gets squared. Okay. So guys, this is how you set up the problem for the first one we're working on. Now, I want to say something here. Okay. Whenever students whenever students attempt to solve out this problem, a lot of students make a lot of mistakes in that if they're working with a graphing calculator, they'll try to type this whole thing into their graphing calculator, and they end up getting something wrong because their order of operations were incorrect. Maybe they forgot to put a parentheses in the right spot. Okay. Now, here is how I would avoid that. Okay. Guys, if you do this method that I'm about to tell you, you're going to get the right answer every time. What I would do, instead of typing the whole thing into your calculator, what I would do, I would type in my numerator first, get a result, then type in my denominator, get a result, write those two numbers down and divide them to get my answer. I would especially do this if you are using the calculator in Google. So let me walk you guys through this. Okay. So if we're using the calculator in Google, this is how we would type this in. So let's type in the numerator first. The numerator is 6.67 times 10, and then you're going to raise that to the negative 11th power. Okay. And then all of that times 5.7 times 10 to the 6th power. All of that times 4.3 times 10, and then remember this button right here is exponential, 10 to the 9th power. Okay. So as you guys see, this is my numerator. So my numerator, I just type all of this into my calculator, and then this is what I get. And then once I do that, I'm gonna press equal. Okay. So notice that is my numerator. So I'm gonna write that number down because that's my numerator. Again, guys, this is the best way to solve this to ensure you don't make any mistakes. So 6, 8, 1, 7. So that's my numerator. Okay. Now, what is my denominator? My denominator is 1,000 squared. So let me put that in my calculator. 1,000, and then I'm gonna square it. So hit this button and hit squared. So 1,000 squared, that is equal to 1 million. Okay. All right, did everybody see what I did? I put my numerator in my calculator first, wrote that number down. Then I put my denominator in my calculator, wrote that number down, whatever my result was. And now I want to take these two numbers and I want to divide them. Can someone divide these two numbers and tell me what you guys get for the force of gravity? Anyone? Yes, Angelina, that is correct. Thank you, ma'am. You get 1.63 newtons. So that is our answer for this problem right here, 1.63 newtons. That's the number for the force of gravity between those two masses. Any questions on what I did? Guys, are y'all clear on what I did? I didn't move too fast, did I?
Yeah.
Awesome. Very good. Yeah, so you're just using this equation right here whenever you're working out your mathematical problems. G is the gravitational constant, which is always 6.67 times 10 to the negative 11. Okay, Stephanie, R always stands for, okay, in this equation, R always stands for the distance between the centers, always. And look, in the problem, it tells you the centers of both objects are 1,000 meters apart. So it told you that. Does that make sense, Stephanie? Yeah. So it told you, it said that, yeah, they're 1,000 meters apart. That's how far the centers are apart. So it told you that. So R always means the distance between the object centers. Again, so guys, for all these mathematical problems, you're going to use this equation right here. Force of gravity is equal to big G times the mass of the first object times the mass of the second object. Divide that by the distance between the object's centers squared. And guys, you always want to square R, always. So,
Well, did you move on to another question?
Say it again.
Did you move on to another question?
Yeah. Here I just put the answer for this right here. It's 1.63. That's the one we just did.
All right.
Now, I want to say this, guys. If you look at some of these questions here, like for example, look at this question right here. It says a 6.5 times 10 to the 24 kilogram object is 3.2 times 10 to the 4 meters apart from a 3,800 kilogram object. Calculate the force of gravity between them. Guys, whenever you're calculating the force of gravity and you're plugging in R here, since this right here says we're dealing with an object that's 3.2 times 10 to the 4 meters apart, we know this is R because meters, that's a distance, right? So whenever you're plugging in R into this equation, do not forget to square R. Students always forget, well, not always, but sometimes students forget to do that. But it happens every year that at least one or two students may forget to square R. So for example, if I wanted to square this in my calculator, it would look something like this. It would be, I would put it in parentheses. I would do 3.2 times 10 to the 4. Hold on, let me make sure I'm in parentheses. I would do 3.2 times 10 to the 4th power, and then close parentheses, and then I would square everything in parentheses. So guys, whenever you're squaring exponentials, you would do it like this. So again, this number right here, if you're putting that in your calculator and you're squaring that 3.2 times 10 to the 4, that's how it will look like in your calculator. Please be sure to put that in parentheses before you square it, just so you get everything correct. Do not forget to square R. Students, for basically happens so much that I have to reiterate that you guys should not forget to square R. Any questions so far? We're not done because there's some more things I want to talk about before I let you guys go to do this on your own. I don't know. Why am I pressing that? I don't know what that number is. Now, guys, some of these problems deal with the difference between weight and mass. Irina, what are you talking about the answer? You talking about the answer to the very first problem I did? I've only done one problem. I give you the answer. Are you talking about that first one I gave you that was 1.63 newtons? Yeah. The answer was 1.63 newtons. The other ones I want you guys to figure out on your own. Now, guys, whenever we're working this out, I want you guys to know the difference between mass and weight, because we talked about this last semester. Hopefully, you guys remember this. So, guys, imagine that I'm standing here on the surface of the Earth, and I want to know what my weight is. And guys, this was something we talked about last semester. Remember what I said? An object's weight is exactly equal to the force of gravity acting on the object. Weight is equal to the force of gravity acting on the object. So because I'm standing here on the Earth, it should be obvious to you guys that there's a gravitational force that's pulling me toward the center of the Earth. Okay. This gravitational force is what's responsible for my weight. Okay. And guys, if you guys remember, if I want to know my weight here on Earth, I would just calculate the force of gravity here on Earth. And remember, the equation for the force of gravity here on Earth is mass times 9.8. Mass times 9.8. Do you guys remember working with this equation right here? Do I remember working with this equation last semester? Okay.
I know what 9.8 is.
Yeah. So just know, whenever you're calculating the force of gravity here on Earth, you're just going to use this equation here, which is the object's mass times 9.8. Also, I want you guys to be to know that weight is something that can change throughout the universe. So, for example, let's say I have a weight of um, I don't know 800 newtons here on Earth. If I had a weight of 800 newtons here on Earth, my weight would be different on Jupiter. Why? Because Jupiter is more massive than the Earth, so it has a stronger gravitational pull. So I would weigh more on Jupiter than I would here on Earth. Okay, just something to keep in mind. However, my mass stays the same. Mass just means the amount of stuff that makes me who I am. So, for example, if my mass is 75 kilograms here on Earth, then you can guarantee it's going to be 75 kilograms on Jupiter. It's going to be 75 kilograms on the moon. Mass stays constant. Okay. So that's the difference between weight and mass. Mass, by definition, is just the amount of stuff that makes up an object, which is the same wherever you are. Weight, by definition, is a result of the gravitational force pulling on you. So weight can change, mass cannot. Do y'all remember talking about that? Everybody good?
Yeah.
Awesome. So with that said, guys, uh, uh, let us look at this. Let us look at a few problems here. Look at this problem right here. I'm gonna help you guys out with this one right here. Guys, go to this problem right here that says a 35 kilogram object is on the surface of Venus. Venus has a mass of 4.87 times 10 to the 24 kilograms and a radius of 6.05 times 10 to the 6 meters. What is the mass of the object on Earth? Okay. And guys, go to the specific problem that says, what is the mass of the object on Earth? So it says it starts off, an object is 35 kilograms on the surface of Venus. Okay. No. Oh, crap. I didn't mean to. Now, guys, think about what I just told you all. Here on this problem, you don't have to worry about doing any calculations because remember what I just said. Mass does not change. Your mass is the same everywhere throughout the universe. Yeah, the total amount of stuff that makes you who you are is the same. So guys, if an object has a mass of 35 kilograms on Venus, what must be its mass on Earth? Anyone? That's just obvious. If it's 35 kilograms on Venus, its mass on Earth is just what? Anyone? Mass stays the same.
It'll be the same thing.
It'll be the same thing. So if it's 35 kilograms on Venus, then that means it must be 35 kilograms on Earth. So guys, that's your answer for that question.
Ooh.
Yeah. So the mass of the object on Earth is 35 kilograms.
Then why would no? Okay.
That's it. That's just your answer. Ignore the extra stuff.
They really added that second sentence for what though? Like,
no reason, just to be sure you understand what mass means. Let's look at another problem that's similar to this. Okay, now this problem is very similar to the problem we just did, but notice the question is different. It says the 35 kilogram object is on the surface of Venus. Venus has a mass of 4.87 times 10 to the 4 kilograms and a radius of 6.05 times 10 to 6 meters. What is the weight of the object on Earth? So everybody got that? In the previous problem, it asked for the mass of the object on Earth. But here in this problem, it says, what is the weight of the object here on Earth? Well, notice, guys, they give you the mass. The mass is 35 kilograms. Guys, anytime you want to know the weight of an object here on Earth, you would just use this equation here. Force of gravity equals mass times 9.8, right? Because if you can solve for the force of gravity here on Earth, then you know the weight of the object. So on this problem right here, guys, if y'all want to know what the weight of the object here is on Earth, you just take the mass and multiply it by 9.8. So I'm gonna leave that to you guys to do.
Wait, what? Say it again.
The equation for the force of gravity here on Earth is always mass times 9.8, Jeremiah. So they give you the mass and they ask you to find the weight. How do we do that? It's just mass times 9.8.
Yeah.
And that's your answer for number 12. Where it says, what is the weight of the object here on Earth? Y'all got that?
Yeah.
Okay, as soon as y'all got that one, I'm gonna move on. Look at this problem here. This problem is similar to, it starts off similar to the problem we just did, but notice that the question that it asks is different. So guys, if you're at your computer, go to this problem right here, where it says, a 35 kilogram object is on the surface of Venus. Venus has a mass of 4.87 times 10 to 24 kilograms and a radius of 6.05 times 10 to 6 meters. What is the weight of the object on Venus? Notice how this is different. In the previous problem, it asked for the weight of the object on the Earth. But here in this problem, it asks, what is the weight of the object on Venus? So how do we do this one, guys?
Are you supposed to use the formula in the second sentence?
Yep, you're going to use this formula right here. You're going to use this formula for force of gravity. I'm going to tell you why you're going to use this formula. Because remember what I said. Anytime you're standing on a planet, your weight is equal to the force of gravity acting on you. Okay. However, this equation right here, everyone in Jeremiah, this equation right here for the force of gravity, this equation only works here on Earth. I'm going to say that. You only use this equation when you're here on Earth. Okay. When you're not on Earth, you need to use the universal equation for gravity, which is this equation here, right? Because if you know the force of gravity, you know the weight of the object, okay? So this is the equation you're going to use to find the object's weight. So let me draw a picture of this. You guys understand what I'm saying? So imagine I'm standing on Venus. So here's the planet Venus. And this is me, and I'm standing on Venus. And let's say I have a mass of 35 kilograms. Okay. So guys, if you guys want to know the force of gravity pulling on me, right? Because it should be obvious to you all that there's a force of gravity pulling me to the center of the planet, right? Venus is literally pulling me toward it. Okay. Just to be clear, I am on Venus. Okay. So Venus is pulling me toward the center of the planet. Okay. If I want to know the weight, in other words, I want to know the force of gravity acting on me. So that's where I would use this equation right here, where M1 would stand for my mass, M2 would stand for the mass of Venus, and in this case, R will represent the distance from here to the center of the planet, which is obvious, the radius. Okay, so if I plug everything in, it would be 6.67 times 10 to the negative 11. All of that times mass of the first object, which is 35. All of that times mass of the second object, which is 4.87 times 10 to 24. And again, that's in kilograms. That's how you know that's mass. And then all of that gets divided by the distance squared. Well, what is the distance? In this case, the distance is just the radius of the planet. And it should be obvious to you guys why that's the distance, because obviously if I'm standing on Venus, obviously the planet is so much larger than me that the precise distance or the approximate distance from my center and Venus center is just the radius of the planet. So I'm going to put 6.05 times 10 to the 6. Okay, because that's the radius of Jupiter. And guys, don't forget that R always gets squared. Okay. So guys, whenever you guys put this in your calculator, remember, do your numerator first, then do your denominator, and then once you divide them, that will be your result. Guys, give me just a second. There's someone at my door. I'm gonna let you guys work on it, get the answer, and then give me just a second. All right, thank you. Okay, any questions on this one? Again, I'm gonna let you guys put them in your calculator yourselves to get an answer.
So when we get a number, is there supposed to be a x 10 to the 16th power next to it?
Are you asking? Does your answer have an exponent in it? No, it should not, because there's no exponents in the. There are no exponents in the problem.
Well, I meant like when I do the top part, it says times 10 to the 16th power next to it.
What say it again?
When I did, never mind.
Okay. Huh? You said 6.67 times 10 to the negative 11? Did you put it in your calculator?
Yeah, I did. I put the top part in my calculator, and I got a number, but right next to the number it says times 10 to the 16th power.
Oh, for your numerator?
Yeah.
Yeah, if you get that only for your numerator, then yes. But what I'm saying is your final answer should not have an exponent. But yeah,
oh, okay.
But yeah, for your numerator, yes, it should. Yes.
All right.
Yeah, when I put in my calculator, I did not get a numerator. For my final answer, I got something that looks approximately close to one of the answer choices. But yes, for your numerator is going to have an exponent. Okay, guys, any questions on this one? Okay. Guys, just remember, if anytime it asks for the weight of an object, remember just remember what I said. Weight is equal to the force of gravity. So in this case right here, if you want to know the weight of an object on a planet, you just use the equation for the force of gravity. Just know that if you're anytime you're on Earth, you can use the equation mass times 9.8. But if you're not on Earth, you're going to need to use the universal gravitational equation. All right, guys, I'm gonna clear my screen here. I'm about to move on. Again, I'm just doing enough of these so you guys can get the idea. Let's see. Guys, on this problem right here, it asks you if you have two objects, one object has a diameter of 12 meters and the other object has a diameter of 8 meters, and it asks you what will be the value of r. Remember what r is. Remember what I said. R is always the distance between the object centers. So in other words, you have everything you need to basically find the distance between, hold on, I'll write this down, the distance between that point and that point. So r is always the distance between the object's centers. So between that point and that point, if you know the length of that line, that is r. Okay, and you guys can easily find that because notice they give you the diameter of this sphere. They give you the diameter of this sphere, and they give you the distance from here to here, so you can easily figure out what r is. And again, I'm going to let you guys do that on your own. Okay. All right, let me see. I think that's pretty much everything that I need to go over. And guys, remember, in this equation here, and this is one of the things he said in the video that we watched on last class period, that the force of gravity is directly proportional to the masses of the objects. What that means is if you double one of the masses, then you double the force of gravity between the two objects. If you quadruple one of the masses, then you quadruple the force of gravity between the objects. That's what it means to be directly proportional. Okay, just something I want you guys to keep in mind. All right. I think that's all I'm going to do with you guys as a class. I'm going to let you guys do the rest on your own. Let me stop sharing my screen. Are there any final questions for me?